All right, guys, a little, I guess, less intense of a topic today. In fact, this is one that we might just let you do on your own, or we might combine it with another lesson so that we have an extra day at the end of the quarter to work on a few things. But what we're talking about is what the meaning of a definite integral is. And Emma asked a great question the other day, and it was one that I didn't realize we had brought up on an earlier assignment. But we are measuring, when we're looking at an integral, we are finding the area underneath the curve, which basically means we're taking our x value and timesing it by our y value, our units, right? So in this case, if I'm looking at what is the meaning of the integral from 0 to 30 of f of t dt, well, first of all, it's an area, and my x-axis is measured in minutes, and I'm going to multiply that by my y-axis, which is vehicles per minute. So when I multiply those, I end up with units of vehicles. So when I'm answering this question, especially on the AP test, don't say it represents. I would say that the integral from 0 to 30 of f of t dt represents the total what? What are my units of my integral? Vehicles. The total vehicles that pass through the toll booth over the 30-minute period from 30 to 60. We've got to be really careful that we include that interval in there. Okay, it's the total vehicles that pass through the toll booth between 0 and 30 minutes for that 30-minute interval, or that 30-minute period, okay? The second one, I've got minutes on my x-axis and gallons of minutes on my y-axis. So my units are going to be minutes multiplied by gallons per minute, which gives me gallons. So the integral 0 to 30 of f of t dt represents the total gallons. The total gallons that what? The amount of gas in a gas station storage tank is changing. The total gallons in the storage tank over the 30-minute period. I guess this one would represent if y, let's see, our y value is measuring gallons per minute. So I would assume this means that gallons are leaving. This means that gallons are entering. This means that gallons are leaving. So our total, it would be the total change in gallons, right? This one would be our total change in gallons of gas in the tank. The third one's kind of weird. A boy is fishing and puts his caught fish in a bucket. F of t represents the number of fish that are in the bucket at t minutes. So if I look at my units, I'm taking minutes and I'm multiplying that by fish caught. So my units are like fish minutes, the number of minutes that fish spent in the bucket. So I would say the integral from 0 to 30 of f of t dt represents the total number of minutes that fish spent in the bucket. The total number of fish minutes, or minutes that fish spent in in the bucket. Anyway, moving on. Like I said, today's just kind of a low-key, things aren't too intense. I like this problem a lot. In fact, this is one I really want us to just do together in class. And as I look ahead at what's up and coming and at our schedule, we might not have time to do it in class. So basically, this problem is looking at accumulation functions, and really it's just taking everything that we've done so far and kind of plugging it all into one problem. So the accumulation function is defined as an integral from a to x of f of t dt. Basically, the function of x accumulates the area under f for some constant a to some value of x. Well, we already knew that. We knew that we are accumulating the fish minutes. We are accumulating the the amount of gas that's been changed. We're accumulating the number of, what was our other one? The number of vehicles that passed through at a certain time. So it gives us this function, little f of x this is our derivative. So this is a graph of our derivative. And it wants us to find these values. So it tells me that big F is the integral from 0 to x of f of t dt. So basically, it is asking us to, big F represents the total amount between 0 and whatever x value we pick. So if I pick -1, it wants me to accumulate that area. If I'm going from 0 to -2, I'm accumulating this area. So it's nothing new. It's just worded a little bit different. So the first thing I'm going to do, these go up by 1 for a while. So I'm going to split these into different areas. And I want to find the area of each section just to make this a little bit easier. So right here, from -4 to -3, that's a triangle. And that triangle is 1 by 2. So 1 times 2 is 2, divided by 2 is 1. So the area of that triangle is 1. Now the area of the next piece is a little bit interesting because my area over here on the left matches the area on the right, it looks like. And those are going to cancel each other out. So this area from -3 to -2, my total area is 0. Because this positive, and I should maybe be careful, this top part is a positive half, this bottom is a negative half. So those actually cancel each other out. Now from -2 to -1, I just have a rectangle. It's 1 wide, it's 2 tall. So that is going to be 2. And I should make this a -1, shouldn't I? Because we're below the curve. This triangle is 1 wide, it's 2 tall, so it has an area of 1. Once I hit 0, I start going up by 2s. So this semicircle has an area of, well, the radius is 2, so it's pi r squared, so it's 4 pi, but it's a quarter of a circle, so that just means this is pi. That means this one is also pi. And then my area down here, I've got a triangle that's 2 wide, it's 2 deep. So 2 times 2 is 4, divided by 2 is 2, but it's below the line, so it's actually a -2. All right, so let me get rid of some of these little numbers so we don't get confused at what we're looking at. All right, so I've got the area of these different sections. So when it says, like big F of x is -4, it wants me to accumulate from 0 all the way to -4. It wants me to add all of this together. So I've got 1 plus 2 is 3. These halves cancel each other out. And then I got a -1. So my total area from 0 to -4 is 2. Now, we've got to be a little bit careful because remember when I take an integral from 0 to -2? -2 should actually be on the bottom, right? But that's the same thing as 0 to -2. I just have to flip it around. I have to make it a negative. So because I went from 0 to -4, I have to put a negative in front of my answer because my bigger number was on the bottom. Now, when I go to -3, I'm going to go over 1 over 2. This next one's going to cancel out. So that's 3. But because my bigger number is on the bottom, I've got to make that a -3. When I go to -2, my answer is also -3. When I go to -1, I have an area of 1, but it's going the wrong direction, so I got to make it a -1. At 0, I've got an area of 0, of course. At 2, I have an area of pi. If I go all the way to 4, I've got an area of 2 pi. And if I go all the way to 6, I've got 2 pi minus 2, which unfortunately is not a nice number. At least I don't think it, no, it's not going to be a very nice number. So we'll leave it like that. Okay. Now it wants the values, f prime of x. So at -4, I'm just at 0. At -3, I'm at -2. At -2, I'm at +2. At -1, I'm up here at +2. At 0, I'm at 0. At 2, I'm at 2. At 4, I'm at 0. And at 6, I'm at -2. All right, now it's going to ask me some questions. And a lot of these we'll talk more about in class. But it says on what subintervals of -4 to 6 is f increasing and decreasing? Now, the way that we've done this in the past is we've looked at critical values and we've looked at endpoints, right? To see when is, well, I guess that's really, we're probably using that more for our absolute minimum and maximum. Our increasing and decreasing, I guess we can just look at we already have the derivative function, right? So we are increasing when our slope is positive and our value is positive. We are decreasing. Our function is, because it wants to know when our function f, which is right here, which is kind of a weird function, right? It wants to know when our function f is increasing and decreasing. So as I go from -4 to -3, I'm going from -2 to -3. So I'm decreasing. So let's make a list here. When are we decreasing and when are we increasing, right? So I'm decreasing from -2 to -3. But then I kind of stop, right? Because I flatten out. Or not from -2 to -3. Those are my y values. I am decreasing from -4 to -3. And then I stay flat. And then I increase. From -2, I increase to -1. Because when I'm at -2, I'm at -3. We're looking at our f function, right? Yeah, so I'm increasing. I'm looking at my slope. I'm increasing from -3 to -1. I'm still increasing, and I don't know what's happening right at -1. So we're going to say from -1 to 4. We're still increasing. And then from 4 to 6, I'm decreasing, right? From 4 to 6, my function is going down. If I look at the slope of my function, my f of x, we're going down from 4 to 6. So I'm okay with that. That looks good to me. Now it wants me to find the absolute minimum and maximum values of x. So here's where I'm going to check my critical values and my endpoints. And I'm going to plug those into my original function. So my critical values are when my derivative, so when f of x is equal to 0, those are critical values. So I've got 1 right here, I've got 1 right here, 1 right here, 1 right here. And then I also need to check my endpoint 6. So if I do that at 0, I've got 0. Or at negative 4, I've got 0. At negative 2.5, what do I have? I've got 1, 2, plus another half. So I've actually at negative, let me write this down. Let's see, f, big F, of negative 4 is equal to negative 2. Big F of negative 2.5 is equal to, we said 3.5. Big F of, let's see, 0. Oh, I don't know what just happened. Go away. I don't need you. F of 0 was 0. Big F of 4 was 2 pi. And big F of 6 was 2 pi minus 2. So which one of those is the biggest? 2 pi for sure. So that's going to be my max. So there's a maximum at 4 of 2 pi. And let's see, my minimum is going to be right here at negative 4 because I'm down at negative 2. So I've got a minimum of negative 2 at f of negative 4. All right, on what subintervals of negative 4, 6 is f concave up and concave down? So we've got to look at the second derivative, remember, for concave up and concave down. Really, I'm just looking at the slope of my derivative. So if my slope is positive, then it's concave down. If my slope is negative, let's see. If my slope is positive, it's concave down. If my slope is negative, it's concave up. Or am I writing that down backwards? I think I'm writing that backwards, right? Slope positive is concave up. Slope negative is concave down. So, looking at my interval here, f prime of x, on what subintervals? So from negative 4 to negative 3, I go from 0 to negative 2. So I'm concave down and concave up. So from negative 4 to negative 3, I'm concave down. My slope is positive from negative 3 all the way up to where? My slope is positive until I get to negative 2. And then I don't really know what happens right there. I don't know about my slope because my slope is 0. So I've got to look at my first derivative, my f of x, or my little f of x. So from what, negative 2 to 1, what am I doing? I'm not changing. But if I look at the middle, if I look to the left, I'm negative. If I look to the right, I'm at 0 of my interval. So what's happening is I've got a positive slope, and then it levels out, and then I still have a positive slope. So it keeps going up. So I'm going to say that's still concave up from negative 2 all the way up until -1. But then look at -1. At -1, I'm concave down until I get to 0. At 0, I'm concave up until I get to 2. And then I'm concave down again. My slope is negative from 2 all the way up to 6. My slope is going down, right? Negative slope, negative slope, negative slope, negative slope. And I'm still have a negative slope. So when I sketch this, this is where it gets to be a little bit fun. Some of you are really good at drawing these sketches. The first thing I'm going to do is put my points because I know where they are, right? I know at -4, I'm at -2. I know at -3, I'm at -3, and I'm at -3. And I also know that in between them, I'm right here. At -1, I'm at -1. At 0, I'm at 0. At 2, I'm at pi. And at 4, I'm at 2 pi. And at 6, I'm at 6.28 minus 2, so 4.28. So I'm up here. All right. Now, I also know that from, let's see, from -4 to -3, I'm concave down. So if I zoom in a little bit, I'm concave down right here. And then from -3 to -1, I'm concave up. So right here, I'm concave up. Then from -1 to 0, I'm concave down again. And then from 0 to 2, I'm concave back up. And then I'm concave back down. So that is what our function looks like-ish, as best as we can with a crazy function like what we had.